That is also known as.
This call is now being recorded.
So we'll study clipping below reference voltage. Below reference voltage. That is also known as bottom clipping. Bottom clipper. Bottom clipper. Bottom clipper. Okay. Now see the circuit for a bottom clipper. It will be like this. You have an AC source. Then after 10-15 minutes, I'll ask every student to turn on his camera. Okay, be prepared for that. So we have a resistance, then we have a diode, and we have a reference voltage like this. So this one is your reference voltage VR, and this is your output voltage here, V output. This is our input voltage, V input, and then we have a current limiting resistor, which is R. Okay, and if we try to find out here, if we observe V of R here, which is the reference voltage, it is positive. It is positive. I have explained in my previous lectures why it is positive. Okay, and if we try to find out how does the circuit will operate, then I'll explain operation also. Operation. Now see here, if we input case 1, there will be two cases. One will be case 1. One will be if V input is greater than V reference voltage, V input is greater than V reference voltage, V of R. Okay. First of all, if we draw the waveforms here, the waveforms of the circuit will look like this. This is V input. Somewhere maybe like this. So this is my V input. Okay. And I have a reference voltage, which is a positive reference voltage. That will be somewhere here. Positive reference voltage, which is V of R. Okay. Now see, if V input here is greater than V of R, then we know in this case diode is reverse biased. Diode is reverse biased. Okay. So I will ask Abrar, why is diode reverse biased? Abrar? 54. Why is diode reverse biased? Sorry, Abrar is not here. Arba, roll number 70.
Yes, sir.
Why is diode reverse biased? Uzma is here.
Sir, N is no more.
Yes, sir.
Uzma, beta, why is diode reverse biased?
So because Vi is
Am I
greater than.
audible now?
Yes, you are audible.
Sir,
Abrar, I'll
repeat.
ask same question.
Okay, sir.
Why is diode reverse bias in this case? Abrar will explain.
The N is more positive there, na?
Which is more positive?
N.
Yes, N side is more positive. N side is more positive. It is more positive, or it is having higher potential. It is having higher potential. Okay. So in this case, reverse bias, diode is reverse biased, then we can say that equivalent circuit of the diode is open circuit. Equivalent circuit of the diode is open circuit. If we redraw the circuit in this case, then the circuit could look like this. This is V output. Then we had somewhere a diode which is open circuit, and we have a reference voltage VR. Okay, then this is V input here, and V output is collected here. So Arba will tell me, Arba, what will be V output in this case?
सेकेंड सो जब ओपन होगा
What will be V output?
V के बराबर
Yes, V output will be equal to V input. V output will be equal to V input. So this is the first case. Okay, this is the first case. Whenever input is above reference voltage, greater than reference voltage, your V output will be all the way equal to input. Okay, but what if the case is other? Case second, if V input is less than V of R, if V input is less than V of R, in that case, our diode is forward biased. Our diode is forward biased. Then the equivalent circuit of the diode will be a short circuit. It will be a short circuit if we are assuming ideal diode model. Okay, then therefore uh, Mahvish will tell me what will be output of this case now. Now the circuit
So
is
we
like
are equal
yes, Mahvish.
V reference.
Yes, it will be equal to V reference. This is V output. So this will be your circuit now. Now V output here, it will be equal to V reference. The output will be V reference. So these are two different results in two different cases. We have to now plot it. Okay. So this is my input somewhere here. Say for example, I am plotting output here now. When I plot output, so I have to first bring all those crossing points. All those crossing points which are in the input waveform. Now see, this area is this one. This yellow area is when V input is greater than VR. Okay, when V input is greater than VR. In that case, your output will be always equal to V input. But the rest of the area, which is all the way this much, this is all that area where V input is less than VR, where V input is less than VR. So for this entire area, which is the blue one, the output is constant. It is equal to VR. Okay, as per case 2, it is equal to VR. It is equal to VR. So we'll draw it like this. Suppose this is the reference line. This is VR. Okay, if this is the reference line, then whenever whenever input is less than reference voltage, then your output is constant. So this entire area is constant here. Okay, it is constant, and whenever V input is greater than VR, then it is equal to input. So this will be the output waveform of the circuit. Now if you see here in this waveform, we have basically chopped off this portion of the region, which is the bottom of the signal. this bottom of the signal has been chopped off. Therefore, this is known as bottom clipper, or this is a case of clipping below reference voltage. It is the case of clipping below reference voltage. So in this case, a portion of input signal which lies below reference voltage is removed by the circuit. Okay, so I'll say bottom clipping. In this case, a portion of input signal which lies below reference voltage is removed by the circuit. Therefore, this circuit is known as bottom clipper. It is known as bottom clipper. Okay, so this is input and output. We can now straight away move to VTC, voltage transfer characteristics. Voltage transfer characteristics. So VTC for the circuit. Okay, and you know that VTC is always plotted. It is a curve between input and output of the circuit. Okay, it is a curve plotted between input output waveforms, input output voltages of a circuit. Okay, somewhere here. Okay, now see, here we had positive reference voltage, so we have marked, this is V output here, this is V input. We have marked this positive reference voltage both in input and output line, both in input and output waveform plot. So we'll mark this here also. Suppose this is the reference voltage if it is an input line. And please note that this reference voltage is positive. VR is positive. And output, in the output waveform, VR is still positive. It is still positive. It is still positive. Okay. So we'll mark it on the output line also. Suppose this is the point where it is positive. Okay. This is the point where it is positive. And this is the point of intersection. This is the point of intersection. Now see, when V input is greater than VR, when V input is greater than VR, V output is equal to V input. V output is equal to V input. Maybe Ubair will tell me what will be the plot of this curve when V input is greater than VR. When V input is greater than VR, how will I plot this curve in VTC? So we are referring to straight line, inclined or parallel to V input axis. This is the region where we are interested in. Inclined, yes, it is inclined. Okay, so inclined here at 45 degrees. So it will be like this. Okay. सईद फहीम इसके बाद क्या होगा बेटा?
यस सर।
क्लियर?
यस सर।
क्या होगा यहाँ पे? आप कैसे प्लॉट होगी फॉर वी इनपुट लेस देन वी रेफरेंस वोल्टेज? फॉर वी इनपुट लेस देन रेफरेंस वोल्टेज वी आउटपुट वी आउटपुट इज वी आर। शेख लुबना बताएगी।
Sir, I think it will be constant.
It will be constant? Why do you think so?
Sir, because it is V naught is equal to VR.
It will be constant. Okay. So because we are referring to this region, Okay, so it will be constant. It will be constant. तो ये ऐसे होगी, कुछ ऐसे. ठीक है, तो इसका VTC ऐसे बनेगा, इसका VTC ऐसे ही बनेगा. Now, I'll not go for analysis part now. I'll just change the reference voltage. Now, if reference voltage is here, reference voltage was positive. Okay. किसी को कोई सवाल तो नहीं है? Do you want me to repeat it? किसी बच्चे को कोई सवाल तो नहीं? So I was referring to VTC. Now see, if I will change reference voltage, what if VR is negative? VR is negative. अभी यहाँ रेफरेंस वोल्टेज थी पॉजिटिव. ओके, अब्रार कीप इट ऑन, अपने कैमरे को ऑन रखो बेटा. तो व्हाट इफ द VR is negative? If VR is negative, if VR is negative, in that case your reference voltage will be negative. I will not go for analysis part. I'll just draw the waveforms. You can understand this thing. आप इसको घर में थोड़ी प्रैक्टिस करें. So suppose this is my input voltage or input signal, V input, okay, and this is time axis. In this case, now my reference voltage is, it is negative. Okay, so this is my V of R, and V of R is negative. V of R is negative. All right, let me drag it somewhere here. Okay, so if VR is negative, then the output will be something like this, because it is a bottom clipper. Sorry, yes, it is a bottom clipper. It is a bottom clipper. In that case, your output will look like something this. You will draw all the projections of intersections. That will help you in drawing this waveform. Then this will be all okay. ये ऐसे है, ठीक, यहाँ से यहाँ जाएगी, and then probably like this, because it removes the bottom. The bottom is flat here. The bottom, yes, it is bottom clipper now. Okay, this is a flat curve. And here we have reference voltage somewhere here. This is V of R, which is basically negative reference voltage. In that case, this will be negative voltage. तो इसमें जो cases होंगे, इसमें भी यही case होगा when V input is greater than V of R. ये एक case होगा इसमें. In that case, V output is equal to V input. Another case will be when V input is less than V of R, then V output is equal to V of R. Okay, basically minus V of R, because here V of R is negative. Okay, so it will be equal to minus V of R. Minus V of R. All right. Now, if I draw voltage transfer characteristics, Aruja will help me in drawing the voltage transfer characteristics of the circuit. So, Aruja,
Yes, sir.
जी बताओ बेटा, इसमें जो y एक्सिस है वो कैसे मार्क होगी? y एक्सिस को क्या मार्क करना है?
सर जो हम V आउटपुट है और V इनपुट जो है x एक्सिस पे रखना है.
v इनपुट, ठीक है, ओके. तो इसके बाद क्या क्या करना है हमें VTC के लिए?
सर हम लोग को V रेफरेंस पहले देखना है कहाँ पे आएगा. ठीक
है, रेफरेंस वोल्टेज राइट साइड से आएगी कि लेफ्ट साइड से?
सर लेफ्ट साइड से, क्योंकि दोनों नेगेटिव है.
ओके, चलिए यहाँ एक है माइनस V ऑफ R, और ऊपर?
नो सर, नीचे.
नीचे, ओके,
नेगेटिव में.
चलो यहाँ पे भी माइनस V ऑफ R, because V of R is negative. Okay, V of R is negative. ठीक है. So what will be the VTC if V input is greater than VR?
सर ये रैंप फंक्शन होगा नीचे जहाँ पे ये मीट करेंगे ये दो वी आर, वहां से फिर लाइन आएगी स्ट्रेट।
वेरी गुड, ठीक है। सो इट विल बी a ramp function like this as said by Aruja. देन जहाँ ये मीट करेंगे वहां से कांस्टेंट होगी, ऐसे होगी। Aruja, ठीक है ये। So this is V output is equal to V reference voltage, okay, and this is the portion where V output is equal to V input, okay. So in this portion also, this is the portion where V output is equal to V input, and this is the portion where V output is equal to V of R, V of R, V of R, ठीक है। तो यहाँ पे भी ऐसे ही VTC बनेगा, and you know how to find these reference voltages, how to locate whether they are positive or negative. Is it fine? अबरार बेटा, आपको समझ में आया?
जी सर।
कोई सवाल तो नहीं है? शोमिया को कोई सवाल तो नहीं है? शोमिया, आपको बेटा?
नो सर ठीक है।
अच्छा, चलिए, अभी तक तो हम कर रहे थे आइडियल मॉडल ऑफ डायोड. We were assuming that the diode is replaced by ideal model, and in ideal model we know that diode is replaced by a short circuit. Okay, diode is replaced by a short circuit. We can also use constant voltage model. Okay, so let us analyze this. Analysis using constant voltage model. Okay, analysis using constant voltage model. And you know, in constant voltage model, diode, okay, equivalent circuit of diode, equivalent circuit of diode. What is the equivalent circuit of diode, Fazan, in constant voltage model? Fazan, yes, what is the equivalent model of diode in constant voltage model? Equivalent circuit? What about Rizwan?
जी सर।
What is the equivalent circuit of diode in constant voltage model?
सर ये होगा रिप्लेस बाय नी वोल्टेज।
Knee voltage, very good. So it will be a voltage source. Okay, V gamma, V gamma or V knee, V knee, कुछ भी कहो इसको, ठीक है। तो एक डायोड को रिप्लेस किया जाता है नॉट विद शॉर्ट सर्किट, ठीक है, नॉट विद शॉर्ट सर्किट बट विद ए कांस्टेंट वोल्टेज source. That is what is known as constant voltage model. Okay, now see, the question asks that in the circuit shown below, V input is say for example 10 volt peak sine wave, this is one thing. Another one is given that V of gamma, which is the knee voltage, it is also given as 0.7 volt. That means it is silicon based diode, it is made up of silicon. Then the question asks that plot the output waveforms, output and transfer characteristics. Okay, so what is the circuit then? The circuit looks like this. V input, You know that what is V input? V input is 10 volts peak sine. It is a sine wave with 10 volts peak. Then you have a resistor here, and you have a diode also here. This one will tell me how will be its output. How will we plot its output? So this is V output, and you have this voltage, which is 4 volts. Naturally, this voltage is the reference voltage. Okay, reference voltage. So Rizwan will tell me which kind of clipper is it? Bottom clipper, top clipper?
Sir, bottom clipper.
It is a bottom clipper. Okay, जो हमने अभी अभी circuit पढ़ा. So it looks like this. It is entirely similar to this circuit. So it is a bottom clipper. No need to go for analysis. इस वक्त आप इसको लिख भी सकते हो, cases वगैरह drive कर सकते हो. But we have studied it, just now, moments before. So it is a bottom clipper, and we know for a bottom clipper, the output or input-output waveforms could be plotted like this, something like this. Yes, रिजवान कैसे करेंगे बेटा इसका इनपुट कैसे करेंगे प्लॉट वी इनपुट
Sir, sine wave with 10
साइन वेव and what is the amplitude of that sine wave?
10 volts.
Yes, something like this. So we are only concerned about its peak voltage because peak voltage is given. So this is the peak voltage. Okay, so let me not draw the peak voltage here. Let me draw it here, somewhere here. It is 10 volts peak. Similarly, minus 10 volts peak here. Okay, now we know what is the reference voltage. The reference voltage is positive or it is negative? This one?
Sir, positive.
Positive. Okay. So suppose this is the reference voltage VR and which is positive 4 volts. Okay, reference voltage भी दी गई है 4 volts ही दी गई थी. हाँ 4 volts है. तो 4 volts दी गई है रेफरेंस वोल्टेज. अब बताइए इसका इक्विवेलेंट सर्किट कैसा होगा? इसका इक्विवेलेंट सर्किट होगा the diode will be replaced by its equivalent model and the circuit would be like this. This will be 10 sine theta. V input will be equal to 10 sine theta maybe, and this is some resistance here. Then instead of diode we will use its equivalent circuit. Okay, its equivalent circuit. So let us assume that we are keeping diode also. When the diode will be forward biased, then we'll short circuit it. When it will be reverse biased, we will open circuit it. But we will keep in parallel to this its equivalent voltage model also intact. हम इसके parallel में इसका equivalent voltage model भी डालेंगे. So because P side is on the bottom side, तभी मैंने जो रेड कलर का वोल्टेज सोर्स है इसका P नीचे से रखा और N ऊपर से रखा. तो this is 4 volt reference voltage, this is 0.7 volts, and this is your output, V output. Okay, this is V output. So Rizwan, what will be the net effective voltage between these two points due to these sources?
Sir, 4 minus 0.7.
4 minus 0.7. Very good. It will be 3.3 volts. ठीक है, क्योंकि इनकी पोलैरिटी डिफरेंट है और क्योंकि जो स्ट्रॉन्गर वोल्टेज सोर्स है वो नीचे वाला है 4 वोल्ट वाला, इसलिए पोलैरिटी उसी की रिटेन होगी जो नीचे वाला है. तो पॉजिटिव ऊपर से रहेगा, नेगेटिव नीचे से रहेगा. ठीक है, तो अब जो इफेक्टिव रेफरेंस वोल्टेज बनी, व्हाट इज इफेक्टिव रेफरेंस वोल्टेज नाउ रिजवान?
3.3 volts.
3.3. Yes. Now this circuit could be redrawn. अभी ऐसा है, अभी वो सर्किट नहीं रहा, अभी कुछ ऐसा बना. V output is here. This is 3.3 volts. This is R. This is V input. Okay. Now, so we have to rub the output reference voltage now because we have now new reference voltage. अब हमारे पास जो reference voltage है वो नई है, ठीक है? तो हमारे पास नई reference voltage है. Let me draw that new reference voltage like this. V R effective. V R effective is now 3.3 volts. 3.3 volts. Okay. अब अगर हम इसका आउटपुट ड्रॉ करेंगे, since it is bottom clipper, it is not top clipper. Yes, रिजवान कहाँ पे क्लिपिंग होगी बेटा? इसकी रेफरेंस वोल्टेज अब नहीं होगी
सर बॉटम पोर्शन सारा ये
हाँ, तो 3.3 पे अब होगा, है ना? तो कुछ ऐसा बनेगा ये तो कहीं पे इसको ऐसा बन जाएगा, ये कुछ ऐसा बनेगा यहाँ और फिर something like this, then all the way like this. Is it fine? किसी बच्चे को ये एक्सप्लेन तो करना ही करना है. Are you able to understand this thing? बुशरा is here.
Yes, sir.
आपको बेटा समझ आया?
जी, sir.
What about Ikra Ayub?
Yes, sir.
Okay, Shabnam Jan. Shabnam Jan. ठीक है. All right. I'll Okay. Now see, we have studied top clippers. We have studied bottom clippers also, and there are another clippers which are known as two-level clippers. Two-level clippers. So we have studied circuits that can remove top of a signal. We have also studied circuits that can remove some portion from the bottom of the signal. But there are circuits which can remove both top as well as bottom also. Both top as well as bottom also. These circuits are known as two-level clippers, and naturally, as you can predict, they consist of two reference voltages. One is the top reference voltage, a positive reference voltage, because they have to remove some positive portion, some top portion. Another is a negative reference voltage, just to remove the bottom of the signal. So they can remove, we have circuits, they can remove both top as well as bottom at the same time. Okay, so those circuits are known as two-level clippers. Two-level clippers. So they consists of two reference voltages. Two reference voltages. Okay, and what do? They perform clipping. They perform clipping above higher reference voltage. Above higher reference, and also below reference, also below lower reference voltage. Okay, so they can remove some portion at the top and some portion at the bottom, some portion at the top. Now see, the circuit could be like this. I'll just draw the circuit and you will determine its cases and its operation at your respective places. This is an exercise for you. See, this is one portion, and then we may have one reference voltage. This is, for example, VR1. तो रूबा, अगर मैं इतना सर्किट बनाऊंगा, what kind of clipper it will be? तो रूबा,
Yes, sir.
if we complete the circuit up this point only, what kind of circuit it is? A bottom clipper or a top clipper?
Okay, sir.
क्या है ये?
Top clipper.
It is a top clipper? Yes, it is a top clipper. Okay, anyway. And if we add another branch, then this is the bottom clipping branch. And please note down here both the reference voltage they are positive. ठीक है, ऐसा भी हो सकता है both the reference voltages are negative, that will be another case now. Okay, and we have to remember here, since this is bottom reference voltage, this is bottom clipping branch, and this one is top clipping branch. We have two branches here, one is bottom clipping branch and another is top clipping branch. We have to remember here VR1 here must be equal to VR2. VR1 must be, sorry, greater than VR2. VR1 must be greater than VR2. What is VR1? VR1 is higher reference voltage. Okay, and what about VR2? This is lower reference voltage. Okay, this is lower reference voltage. If VR1 is less than VR2, so they should be greater than, VR1 should be greater than VR2. But if somehow you are trying to make VR1 less than VR2, then both the diodes will be on at the same time. Okay, both the diodes will be on at the same time. Both the diodes will be on at the same time, तो then the clipping will not happen. तो इसकी जो इवैल्यूएशन है, इसकी जो ऑपरेशन है एंड इट्स वीटीसी और इसके आउटपुट वेवफॉर्म्स कैसे हैं, आई विल लीव इट टू यू. ठीक है, आप इसको एक बार देखें घर में. तो ये तो है नॉर्मल डायोड्स से. कभी कभार बिकॉज Zener diodes, have you studied Zener diodes? उस्मा बेटा, आप लोगों ने लास्ट क्लास में पढ़ी है Zener diodes?
सर पढ़ा था, यस सर.
सर यहाँ पे जो आपने दिखाया ना, एक तो टॉप क्लिपर भी दिखाया और ये सर एक सर्किट में दोनों क्लिपर्स हो सकते हैं, मतलब
हो सकते हैं. देखिए कभी कभार हमारे, आप ऐसे समझें, हमारे पास कभी कभार सिग्नल आप ट्रांसमिट करना चाहते हैं ऐसे. ठीक है, यू आर ट्रांसमिटिंग ए सिग्नल फ्रॉम ए सेंडर, you have an antenna somewhere here and you are transmitting this kind of signal. Suppose you are transmitting a square wave. This is a square wave. ठीक है, अब इसमें प्रॉब्लम जब आप रिसीवर में भेज देते हैं इसको, दिस इज द रिसीवर, तो बीच में चैनल है ये, एंड चैनल इज फ्री स्पेस फॉर एग्जांपल, या इवन इफ इट इज थ्रू वायर्स या गाइडेड मीडियम. लेकिन कहीं कहीं इसमें क्या हो रहा है, somewhere you have some noise which is getting added up. Okay, and the noise is like this and it is uniform. अब उससे क्या हो रहा है, आपका जो वेव फॉर्म है वो ऐसे बन रहा है, इसका टॉप भी डिस्टॉर्ट हो रहा है, बॉटम भी डिस्टॉर्ट हो रहा है, टॉप भी हो रहा है डिस्टॉर्ट, बॉटम भी हो रहा है. In that case you require special circuits that will remove some portion of its top also and some portion of its bottom also, so that it is purified like this, the way it was before. ऐसे सर्किट्स पॉसिबल हैं, उनको हम कहते हैं टू लेवल क्लिपर्स, जो मैंने एक सर्किट दिया है. अगर आपको ये नहीं आया तो कोई बात नहीं है, मैं दोबारा
सर जो आपने सर्किट बनाया ना, इसमें दोनों रेफरेंस वोल्टेज पॉजिटिव साइड से ही आएंगी क्या?
इसमें दोनों रेफरेंस वोल्टेज पॉजिटिव आएंगी. इसमें एक पॉजिटिव होगा और इसमें एक नेगेटिव होगी, इसमें एक पॉजिटिव होगी और एक नेगेटिव रेफरेंस हो. ऐसा भी, यस, इट कैन बी पॉजिटिव, इट कैन बी नेगेटिव आल्सो. अब देखिए ये एक सवाल बेहतर है, इसमें मैंने कहा ये बहुत सारे केसेस हैं. देखिए कभी कभार ये एक अच्छा सवाल है, मैं बताना चाहूँगा इसका आंसर. कभी कभार आपकी सिग्नल ऐसी है, ठीक है, तो मैंने 3 सिग्नल्स बनाई. ऐसा भी है आप कभी कभार इतना लेना चाहते हैं, खाली ये वाला पोर्शन लेना चाहते हैं, ये तो एक बात हुई. कभी कभार ऐसा भी हो सकता है आप खाली ये वाला पोर्शन लेना चाहते हैं, ठीक है, और कभी कभार ये भी हो सकता है आप कभी कभार ये पोर्शन लेना चाहते हैं. सो यू आर टेकिंग सम पोर्शन, you are removing some portion of the top and some portion of the bottom. So in that case you have sometimes reference voltage is both positive and sometimes both negative, and sometimes you have one reference voltage positive, another negative. ठीक है उसमें level clipping, can be achieved by Zener diodes also. Okay? Because Zener diodes, they act as constant voltage source. Um, okay, they act as sorry as a constant voltage regulator. They act as constant voltage regulator. Therefore, we can also achieve this clipping, whether one side clipping, top or bottom, or two level clipping, with the help of clippers made up of Zener diodes. Okay, so I'll do one thing. I'll make a video lecture on Zener diodes, which will help you in understanding the operation of Zener diode and how it acts as a voltage regulator. Then I'll take this topic once more. मैं एक बार इसको दोबारा लूँगा टू लेवल क्लिपर को. But आपकी just for your curiosity, if you want to check it at your own places, I'll draw a two level clipper using Zener diode. Okay, I'll draw a two level clipper using Zener diode. So this is the circuit of two level clipper using Zener diode. This is V output, this is V input, and this is a resistor somewhere here, and you have one Zener diode. See, this is the symbol of a normal diode. ये symbol है normal diode की, ठीक है? This is a symbolic representation basically. Diodes ऐसे होते तो नहीं है, but it is a symbolic representation of a diode. Symbolic representation of a diode. Okay, and this is symbolic representation of a Zener diode. Symbolic representation of Zener diode. तो इसकी symbol जो है Zener diode की ऐसी होती है. Zener diodes, I'll tell something about Zener diodes. They are just like normal diodes. उनमें जो construction है, जैसे junctions होते हैं, metallurgical junctions, वो बिल्कुल हूबहू वैसे ही होते हैं जैसे normal diodes के होते हैं. The only difference between normal diode and a Zener diode is that the doping level and the doping concentration is very high. It is very high in case of Zener diodes. That is the only difference between a normal diode and a Zener diode. Otherwise, their construction, their architecture, the way PN junctions are connected, it is just similar as a normal diode, as a regular diode. So there is no difference between a regular diode and a Zener diode as far as its construction is concerned, or how many junctions are there. It is same as the normal regular diode. The only thing there is that there's a metallurgical difference. That is, the doping level is very high. Doping level is very high in Zener diodes, and there is a reason why do we want a high doping level. There is a reason also. You must have studied in your electronic devices and circuits. So this is one Zener diode, and this is another Zener diode. They are connected back to back. They are connected back to back. They are connected back to back. This is one VZ1 means Zener voltage 1. This is another Zener voltage VZ2. Here in this circuit, VZ1 will be VR1 and VZ2 will be equal to VR2. Okay. I'll teach you Zener diode also. I'll make a video for that. Please watch that. Then maybe we'll be able to take this discussion. Okay. So as far as clippers is concerned, anyway, I also want to add to two level clippers. In two level clippers, we know that the input output waveforms could be like this. I'm just taking arbitrary signals. So this is a sinusoidal wave. This could be V input, and there could be one reference voltage here, another reference voltage here, and the output of this two level clipper, which is a top bottom clipper, इसका output कहीं ना कहीं ऐसा होगा. It will be like this. Okay, I'm not taking exactly the constraints given. मैंने एक arbitrary input बनाया, उसका ऐसा होगा कहीं. So there will be chopping on both sides. Okay, chopping on both sides. Here, this portion of the signal is removed, and here this portion of the signal is removed. ठीक है, तो इतना इतना पोर्शन अब रिमूव हो रहा है। और इसमें अगर आप देखेंगे VTC, ये तो इनपुट आउटपुट वेव फॉर्म्स हैं, दिस इज V इनपुट and V आउटपुट, ओके, and this is time axis. But if you will see, if you try to plot voltage transfer characteristics, so it could be like this, इसमें ऐसा होगा कहीं। अब जितने केसेस होंगी उतने ही इसमें वेरिएशंस भी होंगी, its shape will also change, but it will look like something this, कुछ ऐसा ही होगा, ठीक है, कहीं ये ऊपर होगा, कहीं ये ऐसा होगा, दिस में भी पॉसिबल एनीथिंग, अभी बहुत सारे केसेस जितनी परम्यूटेशन कॉम्बिनेशन बनेगी वैसे ही होंगे इसमें, तो बट दिस इज हाउ द VTC ऑफ द सर्किट विल लुक लाइक, इसका जो VTC है वो ऐसे ही कुछ दिखेगा। Sometimes we also have special circuits we also have special circuits in two-level clippers that can remove the body of the circuit, body of the signal. So if you have a signal like this, हमारे पास सिग्नल ऐसी है फॉर एग्जांपल, ठीक है, तो कुछ ऐसी है साइनोसाइडल सिग्नल, तो हमारा आउटपुट जो होगा वो कुछ ऐसा होगा, so we have removed some portion of the signal, ठीक है, कितना पोर्शन हमने किया था रिमूव, इसमें हमने इन बिटवीन लिया कुछ पोर्शन, इसको रिमूव किया, इसको रिमूव किया, then remaining portion of the top and remaining portion of the bottom, they are fused together to form to make a new signal, to realize a new signal, okay, तो ऐसे भी सर्किट्स हैं, वो टू लेवल क्लिपर्स में ही आएंगे, आप इनको आगे पढ़ते जाएंगे। So we will go to now next section of our discussion, which is the clampers. Clampers now, okay, clampers. Clampers. Clippers हमने पढ़ा, अब हम clampers पे थोड़ा सा डिस्कस करेंगे, okay? A clamper is a circuit which can add DC voltage or to an AC waveform. So it is a circuit which can add DC voltage to an AC waveform, Therefore, these circuits are known as DC restorers. They are known as DC restorers. They are known as DC restorer circuit. DC restorer circuit, okay? And we should remember that a clamper does not change the shape of the signal. Change the shape of the signal, shape of the waveform, I will say. It does not change the shape of the waveform. Then what does it do? It only shifts the waveform up or down, क्योंकि आपको पता है, if it is adding some kind of DC voltage, I said that it is a circuit which can add DC voltage to an AC waveform. So we have an AC waveform which is which is not having any kind of DC voltage in it, okay, so it adds some kind of DC voltage to the AC waveform and makes it shifted AC. Okay, shifted AC means with some DC portion or DC signal or DC amount present in the AC waveform. Therefore, it is also known as DC restorer circuit. Sometimes once we process the signals in our amplifiers, we remove the DC signal, or a signal it has lost its DC component during amplification. So these clampers are used to restore the lost DC component in a signal. That is why they are known as DC restorer circuits also. Okay, and as I said, it shifts the waveform either up or down. अब अगर positive DC voltage add होगी तो shift up होगा, अगर negative voltage होगी add तो shift down होगा, shift down होगा. तो कभी कभार DC voltage ऐसी भी हो सकती है, negative DC voltage. In that case, it will shift it down. It will shift it down. Okay, तब उस case में shift down होगा. So what are various applications of clampers? Applications of clampers. Applications of clampers. Applications of clampers. A clamper is used. Clamper is used to reinsert or restore the DC voltage. The DC voltage level of a waveform which has lost its DC component during electronic processing. ठीक है, तो किसी भी सिग्नल को जब इलेक्ट्रॉनिक प्रोसेसिंग कर रहे हैं, such as amplification, a signal may have lost its it may have lost its DC component. Then after amplification, once it has lost its DC component, we can use clampers just to restore its DC component back. Okay, so I can draw a diagram here. Suppose I have a signal which is weak AC. I have a weak AC with non-zero DC. Non-zero DC यानी इसमें DC component है कुछ, तो आप उसको एम्पलीफाई करना चाहते हैं. एम्पलीफिकेशन के लिए ज़रूरी है you should remove first the DC component, because otherwise the DC will be also amplified. So you only want to amplify AC component. So we have an amplifier now. So once it will come out of this amplifier, we will obtain amplified AC with zero DC. Because amplifiers do not amplify DC voltages, they only amplify AC voltages. So you will have now zero DC. पहले आपको non-zero DC था, लेकिन अब बना zero DC. तब हम ऐसी सिग्नल में नेक्स्ट स्टेज में एक क्लैम्पर ऐड करेंगे. Clamper we will add in the next stage, so that our signal will be amplified, ठीक है, and with original DC. तो अब इसमें जो होगा एम्पलीफिकेशन भी होगी और इसमें कुछ ओरिजिनल डीसी होगा. ठीक है, and that is why I said that an amplifier is a clamper is also called a DC reinserter or DC restorer circuit. Okay, it is known as DC restorer or DC reinserter. Okay, now this clamper is of two types. Clamper circuit, it can be negative clamper, it can be positive clamper. A negative clamper, it adds negative DC voltage. A positive clamper, it adds positive DC voltage to the signal. Positive DC voltage to the signal. Rehab, roll number 77, is it fine बेटा? आपको समझ में आ रहा है?
Yes, sir. Yes, sir.
कोई सवाल तो नहीं है?
No, sir.
What about Ayman?
Yes, sir.
आपको सवाल तो नहीं है बेटा?
No, sir.
What about Shahid Bashir? DC voltage, and we have two types of clampers. One is negative clamper, another is positive clamper. Okay, negative clamper and positive clamper. So I'll quickly draw negative clamper and then we'll stop. Negative clamper. Negative clamper circuit. Now here, see the circuit looks like this. You have a capacitor here, and then you have a diode in parallel with the output, and our output is here, V output. This is our input here, V input. This is the storage element that I was referring to. Storage element that I was referring to. Okay, so this is a capacitor now. Now see, the capacitor will store the maximum amount of voltage that is applied to it. The maximum amount of voltage that is applied to it. So this is basically the circuit of ideal clamper. Ideal clamper. Okay, in ideal clamper we assume that that diode is short circuit when it is forward biased. In actual sense it does not operate like that way. Anyway, now in this circuit V input can be any AC waveform. Any AC waveform. It can be sinusoidal, it can be triangular, it can be a scale. Okay, it can be sawtooth. Any shape of AC waveform is applicable here as an input. So any waveform. But for sake of simplicity, we will assume that let input be a plus minus Vm square wave. Plus minus Vm square wave का मतलब है that it is a square wave which has positive half and negative half like this. This is for sake of simplicity. You can take an example of a sine wave also, but this will make our analysis simpler. Okay, so this is an amplitude. This is plus Vm here, and this is minus Vm at the bottom. Okay, so it is like this. It is like this. All right. Now, if we assume that here we have, if we assume that Vm is the voltage of the capacitor. Okay, Vm is the voltage of the capacitor. For example, if we assume that Vm is the voltage that the capacitor can store, then whenever diode will be forward biased, whenever diode will be forward biased, then it will short circuit. Okay, then it will short circuit, and whenever diode will reverse bias, then diode will act as an open circuit. If diode will act as an open circuit, then okay, I'll just draw the conclusion from the statements. Now see, in this circuit, when our input waveform is positive, input waveform is positive. Now, once input waveform is positive, that means you have a positive here and you have a negative here. Okay, positive here and a negative here. You should remember that whenever diode, we are assuming that diode is discharged. Initial condition of diode is not charged. And you should remember whenever diode is discharged, it will always conduct. See, if we have a diode like this and we are applying a DC voltage, अब diode जो है वो है discharge condition में, what will happen is that there will be initially the capacitor will act as a short circuit and a very large current will flow, and this current will be like this. इसका जो होगा वो ऐसा होगा, जो graph होगा वो ऐसा होगा. Initially current will be very high, then it will die down to zero. So this is current in the capacitor IC. Initially क्योंकि कैपेसिटर डिस्चार्ज है, कैपेसिटर में चार्ज नहीं है, ठीक है। सो व्हाट विल बी द वोल्टेज डेवलप्ड अक्रॉस द पैरेलल प्लेट ऑफ द कैपेसिटर? इट विल बी जीरो। इनिशियली कैपेसिटर इज नॉट चार्ज्ड, इट इज डिस्चार्ज्ड, इट इज अनचार्ज्ड, ओके, ये चार्ज नहीं है। अब देखिए द वोल्टेज अक्रॉस द कैपेसिटर्स विच इज VC और VM in this case, it will be initially zero. But as the current will flow inside the capacitor, as the charge will flow inside the capacitor, its voltage will develop. Okay, तो इसमें VC develop हो जाएगी and finally it will be constant. Finally it will be constant. And at time t equal to infinity, capacitor will act as an open circuit. Capacitor will act as an open circuit. Why? Because you are applying DC voltage to the capacitor. Please remember that capacitors always block DC voltages. They act as an open circuit for a constant DC voltage. They will always block a DC voltage once they are fully charged. Not in a state when they are not charged. When they are not charged, then they will allow maximum current to flow. ठीक है। So as time approaches to infinity, then the VC will be constant and capacitor will be open circuit. Is it fine? Capacitor will be open circuit. अबरार आपको समझ में आया ये?
जी सर।
उस्मा को भी समझ में आया?
यस सर।
ठीक है, और किसी को सवाल तो नहीं है कोई? I'll stop here. I'll continue from this point in next lecture. ठीक है, अगर किसी को कोई सवाल है आप पूछ सकते हो, otherwise I'll stop.